So today I'd like to model an addition problem as well as demonstrate the partial sums algorithm for addition of a two-digit number. You'll notice that I have unifix cubes for this model, a set of 10, another 10 makes 20, 30, 40, and 8 more cubes makes 8. Actually, normally I'd have these separated into 8 individual cubes. And then down below I have another 10, 20, and 5 more. So I've got my 48 and my 25. In a partial sums algorithm, you're avoiding the issues around regrouping or carrying. So we'd start off and 8 and 5 is 13. And we'd combine the 8 individual cubes and 2 more would give us 10 cubes and 3 more would give us 13. Then we would combine the 40 with the 20. 40 and 20 is 60. And then the step that may look a little different than you're used to, adding those two. So we have 10, 20, 30, 40, 50, 60, 73. So 70 and 3. A slight twist on this algorithm uses the same model, but instead of doing as our teachers always said, start with the ones, and the reason you don't need to start with the ones is that if you're not carrying, it's not going to matter. And so you can work left to right and combine the 40 and the 2 and get 60. Combine the 8 and the 5 and get 13. And then add those together to get 73. The advantage to left to right, it turns out that if we're doing mental arithmetic and trying to do this process in our heads, that idea of creating the larger number and then adding a smaller number onto that larger number in your head, for most people tends to be easier to do as mental arithmetic than creating a smaller number, in this case 13, and adding 60 onto it afterwards. With two-digit numbers, the difference between adding 13 to 60 and 60 to 13 probably isn't that significant. But as you'll see in the next example, when we start working with three-digit numbers, then that idea of the larger number added to the smaller number, added to the smaller number, really does tend to make a difference in how we are able to hold those numbers in our head and remember them. So for this three-digit problem, I've switched my model from unifix cubes to base 10 blocks. Unifix cubes are really nice for 2 digits because you can take the 10 apart and put it back together again. It becomes too cumbersome to try to use them as a three-digit model, so I've switched to base 10 blocks for my three-digit model. Here is my problem: 237 plus 165, and I've modeled on the base 10 mat 200, 10, 20, 30, and 7, 237. And my goal is to add to that another 100, 60, and 5. And so there you see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ones, which in our regrouping model, we'd go ahead and we'd regroup one of those. I'll do that eventually, but for right now, I'm just say, okay, I have 12 of those. 10, 20, 30, 40, 50, 60, 70, 80, 90 in my tens group, and 1, 2, 300. That was the partial sum of the ones, the partial sum of the tens, and the partial sum of the hundreds. Then I'm going to regroup that so you can see that I have my two ones. There was 110 here. We'll add that into the tens. Plus the 9 tens is going to give us 100. And depending on how you want to break this down, you could write 100 and 300. Okay, you'd want to get that 2 in there. 102 and 300. But this can be regrouped as another group of 100, and so we would end up with our final answer of 402. Now, if we took that same problem and worked, I'm not going to use my base 10 blocks this time, I'll just show you the algorithm. So modeling the 3-digit addition, left to right, and partial sums, if we have 100 and 200, we have 300, 30 and 60 is 90, 7 and 5 is 12. If we're doing this as a mental arithmetic, 390, another 10 makes 400, 402. So as a pencil and paper strategy, maybe not the most efficient, but as a mental arithmetic strategy, very efficient based on holding that larger number and adding to that as you go down to the smaller numbers.